Good morning. Today we're going to talk about linear systems some more. Specifically, we're going to keep working with linear systems, and we're going to be trying to find the common solutions for those linear systems. Today, our challenge is going to continue to be that when we're working with these linear systems, they are not going to provide us with the graphs. As a refresher, we're going to start by focusing on our first objective and what a common solution is. Specifically, it tells us understand that a common solution is the set of values for x and y that will work for all equations in the linear system. If we think back a couple days ago, we were providing you with graphs for these linear systems. What makes them a linear system? The fact that they have two or more linear equations at the same time, as we can see on this graph with the red and blue line. You will recall that we found the common solution to these linear systems by looking for the point at which the red line and the blue line crossed each other. That would be a point that is found on the red line and on the blue line at the same time. We know this point here, with an x-coordinate of 2 and a y-coordinate of 4, is the common solution for the two equations in this linear system we're looking at. What that really means is if we took a 2 for x and a 4 for y and plugged it into the red equation, it would work in that equation. That's why it's a dot on the red line. The same would be true since we find it on the blue line. Our challenge today is we're going to take those graphs away from you. We're going to make you figure out where is the common solution when I can't look at it on the graph. There's two basic methods we're going to talk about today. The first would be substitution. We started looking at that yesterday. And the second method would be elimination. The first method we're going to talk about right now is the method called substitution. Eventually, it's going to be your job to identify which of these two methods will better help me solve a linear system. The equations that we're going to look at are y equals 2x plus 5 and 20 equals 3x minus 4y. The reason I see that substitution is going to be helpful for these equations is because one equation already is set up for substitution, the blue one. Why do we mean it's set up for substitution? It says y equals 2x plus 5, or the y is already by itself on one side of the equation. Just as we used to be able to plug in a number for a variable, like if we thought y was equal to 5, we could change the y in this red equation to 5. We're also allowed to use substitution to plug in other expressions, or things that have variables and numbers in place of our y. In this case, if the first equation tells me that y equals 2x plus 5, then in this linear system, I would be allowed to substitute the y in the other equation and replace it with a 2x plus 5. Why might that be helpful for us? Because when we replace that y with 2x minus 5, 2x plus 5 from that blue equation, we've transformed or changed our equation from something that had two variables, an x and a y, into something that has one variable, all x's, even though it shows up more than once. And as you'll recall from earlier in this year, once I have an equation that has all x's in it, I can solve it. It's going to take a few steps. I will have to distribute this negative 4 to get rid of those parentheses so I can start combining these x's. But after I take those few steps, I'll be able to figure out what x is. Running through that quickly, negative 4 gets distributed to the 2x, and a negative 4 times 2x is going to leave us with negative 8x. The negative 4 also needs to get distributed to the positive 5, and when I do that negative 4 times the positive 5, I'm left with negative 20. At this point, I would see that I have like terms, two x terms on the same side of the equation and combine. That would provide me with 20 is equal to negative 5x when I combine those two terms minus 20. Now that all my x's are on the right, I'll want to move this negative 20 away from the right expression over to the left, and we can do that with inverse operations. We're going to go ahead and add 20 to both sides of the equation. The main reason we're doing that is because we want to get rid of this negative 20 and have all of our like terms and regular numbers over on the other side of the equation. After we do that, then we find ourselves with 20 plus 20, which makes 40. And 40 is now equal to negative 5x. And at that point, we would divide both of our sides of the equation by negative 5, and we would realize that x is equal to negative 8. Once I know what x is, I could take this variable, plug it back into that first blue equation, and now that the x gets replaced by a negative 8 in that equation, I would be able to realize what y is after I do 2 times negative 8 and add 5. Tune into the second video to figure out how you can start working with eliminating equations, or a second method that can help us solve some linear system.